What's up guys, welcome to your 12th PyGame tutorial, and in this tutorial I'm going to show you guys how to use animation and how to make things move around on the screen. Now we already moved around a couple things with like the keyboard and the mouse, but I want to show you guys how to move it around just on its own. So if you ever worked with Ajax before, you probably know how to do this, but anyways, I'm going to show you how So I got my basic background image file and mouse image file with using the background and the ball, and I also converted it to our background and ball. So there you go. So that's what we have to start out. You should know what those things are already. But now what we need to do is go ahead and put those things on the screen. But before we do that, I want to make a variable that's gonna, what we're gonna do is we're gonna change the x coordinate of the ball. So if we're going to change it, we probably need a variable for it. So just set x equal to 0 right now, and I know you don't know what it does, but you will soon enough. So now that we have x equal to 0, and hopefully you have the rest of that stuff, what we need to do is go ahead and blit the background onto the screen. So screen blit, and for our parameters put background, or whatever you named yours. Probably should name it background actually. And you want to position this at 0, 0, 0, 0 so it fits on the screen perfectly. So nothing new with the background. What we do want to change is that ball. So what we want to do is when we blit the ball to the screen, blit, look at that, it already knew what we were going to do. We want to blit the ball, and we want the position to be not fixed. We want it to be, the x coordinate is variable, so x, and then 160 for the y. So its y coordinate is never going to change, but the x is going to change. So you're saying, alright, then make it change. Well, alright, then I will. X plus equal 1. So now what we're going to do is every time this loop refreshes, which should be like every fraction of a second, then we're going to add 1 to the x coordinate. So it's going to start out as 0, and then it's going to go, the coordinate is going to go 1, 160, 2, 160, 3, 164, 165, 160, and as these coordinates change, your ball is going to give the appearance of going left and right across the screen. So again, if we did this, it would do it for a fraction of a second and then go off into like 1,160 off the screen. But what we want to do is, just for viewing purposes, we want to say, alright, when you get to the edge of our screen, which is 640 pixels wide, we want you to start over again at 0, just so we can see what's going on. So let's write a simple if statement. If x is greater than 640, which means if it goes off our screen, what we want to do is reset the x coordinate to 0. And what this is going to do is every time the ball gets to the end of the screen and reaches 640, it's going to pop up back to 0 again. And this is all going to happen real fast just because Python runs really quick, but you'll see why this is useful. So now you see our animation, which our ball keeps going on the screen left and right. And if this is too fast for YouTube, it's too fast even in I'm programming it. But what this happens is the ball starts out at 0, 160 and it travels across the screen until it gets the 640, 160, then it pops back. So I know this probably looks weird on YouTube because of the frame rates and stuff, but this is actually going left to right, then hopping back. So that brings me to another problem, that this is going too fast that we can even see. And there's a way to fix this so you can see it perfectly, and this will give you your animations you want timed exactly how you want it, whether slower than that or God forbid faster than that. So that's what we're going to be going over in the next tutorial, but for now just make sure you learn how to animate simple movement using a while loop and how to change one of the coordinates dynamically. And this is just useful so it goes back and you can view it over and over again and this doesn't go off the screen till forever. So thank you guys for watching that tutorial. Don't forget to check out my next tutorial where I'll show you how to time it better so you can actually view it instead of giving you a seizure. So again, thank you guys for watching. Don't forget to subscribe, and I'll see you next tutorial. What's up guys, welcome to your 13th PyGame tutorial, and in this tutorial I'm going to be going over how to fix that problem we had last time with our animation, and we're going to be able to control the speed based on time. And if you're wondering, alright, why would we want to do this instead of just doing it like we did before? Well, before we had an animation based on how fast this loop could execute. So if you had to move 1 pixel every time the loop execute, it would be faster on computers with a faster processor and slower on computers with a slower processor. And when you're building a game, you don't really want it faster on some computers and slower on others, especially if you're going to have like high scores and stuff like that. So to do this, we need 3 variables. We need the x coordinate. Let's just set it to 0 to begin with, same as last tutorial. The next thing that we need is a clock object. Now in PyGame there's a built-in function called a clock, and this is pretty much a clock on your computer, and this is so you can work with time. So PyGame in the time library or module, and then go ahead and click clock. And after this, what you want to do is set a speed for your animation, and I'm going to set it equal to 250 pixels every second. And once I use these once I use these variables, you'll understand what it does pretty much. So after you got your 3 variables, let me move that down so you can see them. And after you blit your ball, here's what you need to do. The first thing that we need to do is calculate millisecond. So milli equals clock tick. Now, why is this important, you ask? Well, I'll answer that for you. Whenever you use clock tick, it calculates 1 tick equals 1 millisecond. So unlike how fast your loop executes, a millisecond is the same on a fast computer, is a slow computer, whatever. This isn't based on how fast your computer is, this is based on actual time. So now we get a constant across all computers. A millisecond is the same amount of time no matter who you talk to. So once we have a millisecond figured out, we usually want to convert it to seconds. So go ahead and write seconds and set it equal to milli divided by 1,000. And after you write 1,000, go ahead and write .0, or you can just write dot. And if you worked with Python and you follow my tutorials, then you know that whenever you divide by like 1,000, this is going to give you a whole number, and you don't want this. You want the detailed fractions of a number. So whenever you divide by a floating point integer, you get a detailed decimal point answer, and this is going to give you 0.001 seconds. So right now we have the variable 0.001 stored in seconds, and again, this gives you a constant instead of just how fast this loop can execute. So once we have 0.001 seconds, we want to calculate the distance moved. So let's go ahead and click dm and set it equal to seconds, seconds, and we want to multiply it by speed. And again, we made the speed in this tutorial. So when we multiply 0.001 seconds by 0.25, we get the distance moved. So now we can x plus equal dm, which is distance moved. And what this is going to do is move it a quarter pixel, or 0.25 pixels every millisecond, or 250 pixels every single second. So let me make sure I got everything right. Looks like it's all good. I can go ahead and run this. Run module, save it, okay. And now you see we can control the speed of our ball by changing that one speed variable. So now, instead of having this ball speed based on how fast your computer can process it, it's the same on every single computer no matter what. So that is how you can work with speed, and when you include that in your variable, speed pretty much evens out all computers and sets them all at an even level. And again, this is what you want to go for in the effect you want to achieve most of the time. So again, one last time, we started the x coordinate as 0 just because it's a good place to start. After that, we went ahead and opened our clock method, because what this clock object does is it allows you to give a constant across all computers. Next, we set a speed, which was 250, which we were going to use later. We went ahead and found a millisecond, and then we converted it to seconds, and we went, alright, the distance moved is that seconds times your speed, and this gave you a constant for all computers. Again, can't stress that enough, but hey, I'm trying. And then you went ahead and moved that just like we did in the last tutorial. So that is your basics of how you can incorporate time to make speed constant across all computers. So I hope you enjoyed this tutorial. I hope you understand it at least a little bit. So thank you guys for watching. Don't forget to subscribe, and I'll see you next tutorial.